Hello everyone, allow me to introduce myself first. My name is Raya Pakulanang. I am 19 years old. I live in Himalalud, Negros Oriental, and I graduated my senior high at Himalalud National High School from the academic track of Science, Technology, Engineering, Mathematics. And now, I am currently studying at Negros Oriental State University main campus, a first-year college student taking up Bachelor of Science in Mathematics. For today's video, I will be going to discuss the Chapter 2 Methods of Proof, providing examples with solutions. So let's get to it. In mathematics, proofs are arguments that convince the audience that something is true beyond all doubt. In other words, a proof is a presentation of logical arguments that explains the truth of a particular statement by starting with things that are assumed to be true and ending with a statement we are trying to prove. We can use several methods or techniques in building a proof, but there are two major groups: direct proof and indirect proof. So let's discuss first the direct proof. So when we say a direct proof, always assume a hypothesis is true and then logically deduces a conclusion. It is a logical progression of statements that show truth or falsity to a given argument by using theorems, definitions, postulates, axioms, and lemmas. In other words, a proof is an argument that convinces others that something is true. So when we say a direct proof, it begins with an assertion and will end with a statement of what is trying to be proved. The most straightforward in its structure, it is constructed using a sequence of simple statements, starting with a hypothesis and leading to the desired conclusion. So, here is the formal definition of a direct proof. So for example, if P plus Q are both even integers, then P plus Q is even. Let P and Q be both even integers, then P is equal to 4 and Q is equal to 8. To show P plus Q is even, we have P plus Q is equal to 4 plus 8, then it's equal to 12. If P plus Q is equal to 12, therefore P plus Q is even. So next is indirect proof. So when we say an indirect proof, it has two forms: the contrapositive proof and the proof by contradiction. For both of these scenarios, we assume the negation of the conclusion and set out to prove either the hypothesis, negation, or a contradictory statement. Additionally, two other techniques can and will be employed to help us write proof, such as proof by cases and proof by induction. We will look at all these types of proof later on, but our primary focus for this lesson is to understand direct proof, indirect proof, and mathematical induction fully. So first is the contrapositive proof. So when we say contrapositive proof, it is a proof that takes advantage of the logical equivalence between P implies Q and not Q implies not P. So given the example, if P and Q are both even integers, then P plus Q is even. Proof by using the contrapositive: if P plus Q is odd, then P plus Q are both odd integers. Let P plus Q be odd, then P plus Q is equal to 4 plus 8, where P plus Q is any integer. Hence, we have P and Q as both odd integers. Accordingly, if P and Q are both even integers, then P plus Q is even. So next is the proof of contradiction. So when we say proof of contradiction, it is a proof strategy where you assume the opposite of a statement and then find a contradiction somewhere in your proof. Finding a contradiction means that your assumption is false and therefore the statement is true. So given the example, if P and Q are both even integers, then P plus Q is even. So proof by using the proof of contradiction: suppose that P and Q are both even integers, then P plus Q is odd given that P is equal to 4 and Q is equal to 8. Then P plus Q is equal to 4 plus 8 is equal to 12 is not an odd number. Thus, we have P plus Q to be an odd integer in which it's a contradiction to the given statement. therefore, our supposition is false, which implies that if P and Q are both even integers, then P plus Q is even. So for the last one is the mathematical induction. So when we say mathematical induction, it is a fundamental proof technique that is as important as the direct proof, contrapositive proof, and proof by contradiction. So it is usually useful in proving that a statement is true for all the natural numbers n. So here's the example, adding up odd numbers. So we have 1 plus 3 plus 5 and so on plus 2n minus 1 is equal to n squared. So for the step 1, show it is true for n is equal to 1. So we have 1 is equal to 1 squared is true. So for the step 2, assume it is true for n is equal to k. So we have 1 plus 3 plus 5 plus 2k minus 1 is equal to k squared is true. So an assumption. Now prove it is true for k plus 1. So we know that 1 plus 3 plus 5 plus 2k minus 1 is equal to k squared, which is the assumption above. So we can do a replacement for all but the last term. So we have k squared plus 2 times the quantity k plus 1 minus 1 is equal to k plus 1 squared. So we can now expand all terms. We have k squared plus 2k plus 2 minus 1 is equal to k squared plus 2k plus 1. So let's simplify. K squared plus 2k plus 1 is equal to k squared plus 2k plus 1. So as you can see, they are the same. So it is true. So 1 plus 3 plus 5 plus 2 times the quantity of k plus 1 minus 1 is equal to k plus 1 squared is true. And that would be all for this video. I hope you have learned something, guys, about the methods of proof. And once again, I am Rhea Pakulanang. Thank you for listening and bye!